Today we're going to look at the law of conservation of mass. Two words here, and they lead you to what it is. Conservation means to conserve or to keep or to try to stay the same. And mass is anything that has volume and takes up space. So our Earth is considered to be a closed system. That means that nothing is entering and nothing is actually leaving. But how can that be? Every day new stuff is being made, new things are being formed. So what is it being made out of, or how is it being made? Okay, so let's look at this a little more. Okay, so let's look at water. Okay, so this is an example of a chemical equation. So a chemical equation has two parts. If you want to think of it, it has a before part, then the arrow, and then an after part. What we call the before part is we call it the reactants. So the atoms and molecules that are before are reacting. For the example of water, we have hydrogen gas reacts with oxygen gas to form water, which is our product, which we call our product side or our after. Okay? So what do you notice though? You notice that we have 4 green H's. So we have 2 molecules of H2. We know that H2 is diatomic because it's a Hofbrinkel. And then we have O2, which is our oxygen gas. Okay? And it forms 2 molecules of water. Okay? That's a balanced chemical equation. Okay? So how does the law of conservation of mass play into this? The law of conservation of mass states that the mass of our reactants, so our before, will equal the mass of the products, which is considered our after. So let's go back to our water example again. Okay, so our water has, if I have 7 grams of hydrogen and 13 grams of oxygen, well, how many grams of water would I make? Okay, so what's actually happening in a chemical equation, the reactants, bonds are split up. So these 2 H's have to split up, and this oxygen splits up, and they rearrange themselves to form water. So if I look, this oxygen and these 2 hydrogens rearrange to form water, and these 2 hydrogens and oxygen rearrange to form the other molecule of water. Okay, so we're not making new things. We are rearranging atoms to look a different way, and then they behave a different way chemically because they have a different shape or they have a different rearrangement. Okay, so back to the grams. So if I have 7 grams and 13 grams, how many grams do I end up with? Well, it's simply just adding. So 7 grams of hydrogen, 13 grams of oxygen would give me 20 grams of water. Okay, so nothing is lost in our law of conservation of mass because nothing left. Now, how can things stay? Okay, so there's one thing that we have to focus on when we mix chemicals together and we want to look at the conservation of mass. We have to make sure we're doing that in something called a closed system. Okay, so a closed system is a chemical reaction, or the Earth, for example. If I put a lid on something, no products can actually escape. So I have a reaction here. I have my reactants. I have my calcium chloride solution in a vial here sitting in a flask with a lid on, and I have my sodium sulfate solution at the bottom of the flask. You invert the flask, mix them up, put them back on the scale, and you notice that they form something different. So the Ca and the SO4 are now together. They formed a little white precipitate, which you see these little white flecks, and NaCl solution. But these are the products. But what you notice about the mass is that they actually stayed the same. They stayed the same even though we rearranged atoms to form new products because the lid was on, so nothing escaped. if I didn't have a lid on a reaction, and I had reactants sitting here, for an example, I had 100 grams of reactants, mix them up, you would notice a decrease in mass. So a decrease in mass would tell me that I probably have an open system. So there's no lid, products are free to move around and escape. I can't measure things that have escaped, like gases easily go into the atmosphere. So that wouldn't be an indication of law of conservation of mass. I'd have to somehow collect them. Okay, so let's look at a couple more examples. So I have magnesium reacting with oxygen. I have 12.2 grams of magnesium reacting with 8 grams of oxygen. How many grams of magnesium oxide will be produced? Well, simple again. I just said I add these two up, and I get 20.2 grams of magnesium oxide. Okay, so if I have both reactants and I'm looking for products, I add. The opposite of that would be if you were given the reactant, or pardon me, the product. So this reaction here made 40.3 grams of magnesium oxide, and I already know I used 16 grams of oxygen. So how much magnesium was initially reacted to form the 40.3 grams? This one actually becomes a subtraction. So if I take 40.3 grams and I subtract the 16 grams from it, I end up with 24.3 grams of magnesium. Okay. So I hope it helps you. Now, if you want to complete the worksheet, and then just remember reactants make products, and remember to either add together to find the mass or subtract to determine the reactant.